Aloha. You're watching F5 On Demand. And welcome to the first of a new F5 webinar series entitled In 5 Easy Steps, where we showcase the ease of deploying BIG-IP features in 5 easy steps. I'm Peter Silva, Technical Marketing Manager with F5, and to kick it off, we're fortunate to have F5's Michael Falkenrath, Senior Field Systems Engineer, with us today. Thanks for joining, Michael.
Hey, Peter. Thanks for having me.
Right on. So I see on the screen DNSSEC. Is that what you're going to share with us today?
That's what we're talking about today. Yeah, we are implementing some DNSSEC solutions in our upcoming version 10.1.
Well, DNSSEC is quite timely. I've seen a number of articles about DNS, getting hacked and some vulnerabilities. So
sure.
Our viewers are unaware. What does DNSSEC stand for? And give us a little bit background on it, if you don't mind.
Yeah, definitely. Let me go ahead and get to my next slide. And really, the DNSSEC stands for Domain Name System Security Extensions, and it's really just a series of DNS protocol extensions defined in those following RFCs that ensure the integrity of the data returned by domain name lookups. So it's really just ensuring that when you make a DNS request for a particular site, you can, through a public key cryptography chain of trust, ensure that you're getting the correct response. So it's really providing an origin of authenticity, data integrity. So ensuring that that site you're requesting is the site that you're actually getting a host name to IP resolution for. So the servers that should be resolving that site for you are, in fact, the servers that are resolving that site through that chain of trust we're establishing.
Nice. And some of our viewers are obviously familiar with PKI and its encryption use, but DNSSEC doesn't necessarily encrypt it. It more provides the integrity and authenticity, right?
Absolutely. It's really just the integrity and authenticity, just like you said. No encryption is taking place. It's really just providing that chain of trust up the DNS infrastructure to ensure that that answer you're getting is from the authoritative servers.
Cool.
So, why DNSSEC? We use it every day, whether you're sending email, web, doing online banking through SSL or HTTPS. It's used about everywhere, just the human nature of not remembering those IP addresses and having to type in IP addresses for everything. And really, there's been a lot of DNSSEC vulnerabilities that have been exposed in the news. There's been articles even up on CNN.com. I had my mother ask me about that article to see if she was vulnerable. It was kind of funny, but DNSSEC, how it's compromised, spoofing, man-in-the-middle, cache poisoning, things like that. So it's really something that the federal government has taken a good look at. In the last year, the Office of Management and Budget actually has put a mandate out to all the .gov zones or sites that they need to be DNSSEC compliant by the end of the year. So by January 1st, 2010, any .gov site, any authoritative .gov site needs to be answering or providing that chain of trust up to the .gov servers. So ensuring that if you're on IRS.gov or another government site, that you can ensure the authenticity of that answer up to the root or the .gov root servers.
Right.
So, really, go ahead, Peter.
No, what I was saying is, if I remember correctly, when DNS was designed a couple decades ago, it was initially designed for that speed and scale, not necessarily security.
Absolutely right. And the big scare there is really on my second bullet, the redirection. Giving the ability for a hacker to come in and through a race condition, being able to intercept that DNS request going to the authoritative name servers and sending a phony response back and mimicking up the look and feel of the site that you think or believe you're going to, and then stealing some of your sensitive information, whether that's username or password or, even worse.
Right. And I think you kind of show the steps, yeah?
Yeah, I do. Let me, your typical DNS infrastructure, a user makes a request for the particular site. It gets to the authoritative DNS server through the normal hierarchy, and they get an answer back, and the world is good. You get to your site, your information is protected. The problem is rogue servers can poison the DNS cache, and we really need a method of trusted responses. So a hacker can actually get in the middle of this whole conversation between the recursive name server and the client. So, this DNS server, this hacker, actually through a race condition. So if the hacker can actually get a response back to that name server, that recursive name server, before the authoritative name servers respond in the normal DNS world, that hacker's response wins. So it's really a race condition of who can respond first. Because that hacker was able to get in the middle and respond more quickly, when the next user or the user makes the request for siteexample.com in this example, he actually gets that bogus IP address back and gets redirected to that hacker site where he can then gain additional sensitive information on that particular user, like mimicking up what his banking site looks like, so that he thinks that he should actually type in his username and password. He's doing normal banking on what he thinks is his banking site. Little does he know, on the back end, the hacker's got his username, password, and he's transferring his funds to an offshore account.
And this doesn't only affect that single user. It can affect many thousands of users.
That's right, yeah, because that DNS or that hacker got in the way. He's setting all those DNS properties as far as the TTL is concerned and things like that. So, hey, here's this bogus answer recursive name server, and it's good for 24 hours. So any other user that was to come and hit this recursive name server along the way of trying to get that response is going to get that phony answer back every time. So, it does, yeah, like you said, it doesn't affect one people. It can affect hundreds, if not thousands.
And so how do we solve this? How does BIG-IP solve this dilemma?
So GTM, or the combination of GTM, LTM, can provide DNSSEC signed answers when we're doing our normal global server load balancing or when we're virtualizing a current DNS infrastructure and providing high availability and horizontal scale. So we've got the ability to configure DNSSEC signing all within our GUI, which is a very, very kind of what we've been calling internally the easy button for DNSSEC signing. So if you're configuring things in Bind, it's a very complex process. You're down in the command line. You're running different scripts to generate keys and sign zones and things like that. And we've basically taken that and put it all within our GUI. So basically in about 4 easy steps, we can set up DNSSEC signed responses from our global traffic manager.
In 4? Oh, so I see the lock there, yeah.
Yeah, so I just was kind of going through, I didn't want to go all through the DNSSEC, the DNS hierarchy again, but basically what you're providing, we're really providing a chain of trust all the way up to what eventually, when the .coms and everyone take this over, all the way up to the root name servers. Because really when a user is going through the whole DNSSEC hierarchy, we're really providing that chain of trust from the root servers down to the .com servers, down to the authoritative server for, in this example, xyz.com, so that there's a validation from the root all the way down to each authoritative server for each respective zone to ensure that the answer you're getting is a fully trusted answer all the way back up that entire DNS hierarchy.
Right. That's very cool. So can you show us in the GUI how we can do this in less than 5 easy steps?
I believe I can. Let me just go over here and share my GUI real quickly.
Oh, yeah, we can see you now.
Okay, great. So I'm in my Global Traffic Manager section. Everything looks the same look and feel as it always has. You'll see 2 additional sections right at the bottom, the DNSSEC zone list and the DNSSEC key list. So the first thing you're going to start with is the DNSSEC key list. And there's really just two keys that you need to create. So let me go into the creation of one of my keys, xyz.com. I'll just use a generic host name or domain. And there's really 2 keys that you need. You need a key signing key, and then you need your zone signing key. I'm going to go ahead and create my key signing key. That's kind of your master key to your whole kingdom. I'm going to make that a bit length of 2048. Usually your key signing key is a stronger key. Here's a good point, too. We've actually we sell a lot of fixed SSL accelerators within the government space as well. And we also, with the solution, give the option to save these DNSSEC keys within a FIPS 140-2 Level 2 hardware secure